So, association areas. Association areas means it will not able to not would be concerned with movement or any particular function or any particular sensation like motor or visual or auditory or any sense. But it is the thing that any other all persons have individually have other things, like means it is the area which all, if there are five members, in the five members they are the other association areas. Okay, association areas is the only area which give a personality. So I am like that. I am behavior. Sorry, not behavior. My talking, my way of talking, and my way of thinking, my way of listening is different from other person. How? Because of the association area. And my way of learning, my way of memorization is other than other person, and my way of learning is different because of association areas. Okay. Although much has been learned about the formation of memory, the process are still incompletely. But we know about the memory. It is a vast process. Now the studies are going on about the memory, how it form, how it will work, how it will be stored, okay, and how it will be demolished, okay, everything. Okay. So basically, the memories are the related with the hippocampus area in the brain. Okay, it is connected to the temporal lobe on the lateral ventricle. The two hippocampi. We have two hippocampi. We'll see in the okay image. It will connect the information from many areas of the cerebral cortex. What it will do? It will collect the information because of the memory. It want to store the memory. So that's the reason it will collect all the information from the cortex area. Okay. When you meet a friend, for example, the memory emerges as whole. Here, he is friend, not in pieces. Because people whose hippocampi are damaged cannot form new memories that they last more than a few seconds. So basically, example is given here. When you meet a friend, so related to the friend, everything, yeah, you will come onto your imagination. You know his name, you know his face, you know his home, you know that you have been friends from past 20 years. Everything, it will clear picture in front of you. So why this is happened? Because of hippocampus. Hippocampus will release all information at a time, that that you can meet your friend very easily. So this is the memory where it will still be stored in the hippocampi. But whose hippocampi are damaged, they are unable to get the information. Within seconds, they will lost all those memories. Okay. The right hippocampi. So this is a very, very important. You have to listen. The right hippocampi. Here we have the right hippocampi is also believed to be involved in a spatial cognition. Means literally space thinking. For example, if you are in school and your friend asks you the shortest way to your home, you will probably quickly form a mental map. You can see how much memory that involves, streets, landmarks, and so on. But the hippocampus can take it a step further and make your memories three-dimensional and mentally visible. You can see your way home. This is spatial cognition. So basically, this is the right hippocampi work is for spatial cognition. Means it will recreate the memory, and as well as it will give to your imagination, recreate the memory. Okay, first thing is recreation of the memory, and second thing is it will visualize that memory, and third thing is it will uh, give the idea what you have to be follow. Okay, it recreate the memory and give the visualization of that area, and it will give the third thing, it will and in the ending it will give to you idea what you have to do. So this is about right hippocampus. Here you have the right hippocampus. We will see in the image. Okay. So means one example is given here. If anyone asks you, how to go to the market, how to go to the clinic, how to go to the market, how to buy a apple, everything, anything, any questions he asked. First thing is you ask the area how to go to market, you visualize that. Mean recreate the memory. Means this is we have to take the right, first right, then left, then right, then you have the market area. This is the memory. You recreate the memory. Second, visualize that memory. Means this is the they are the one shop near. Then there you have to take the right. There is another shop. Okay, then you have to take the right, the left. Then you behind the road, behind this complex, you have that shop or market. This is visualization. And third thing, you have two ways. There are two ways. One is longest way, one is shortest way. Then they give the idea to that person that please follow the shortest area. Please follow the shortest area. So this is how right hippocampus work. Okay. It is believed that most, if not all, of what we have experienced or learned is stored somewhere in the brain. Sometimes a trigger may bring back memories. A certain scent or a song could act as a possible triggers. Then we find ourselves recalling something from the past and wondering where it come from. The loss of functionality due to the destruction of the brain neurons is perhaps most dramatically since Alzheimer's disease. So this is what happened in the hippocampus, the Alzheimer disease. In the Alzheimer disease, we lost the function of the neurons. Okay, due to that, we lost our memory. Next is basal ganglia. Let's see the hippocampus. Mhm. This is the hippocampus. You can see. You can see that this is the hippocampus. This is the hippocampus. In the frontal area, lower part of the frontal area. Okay. Next, we will talk about basal ganglia. The basal ganglia are paired masses of gray matter within the white matter of the cerebral hemisphere. They function as certain subconscious aspects of voluntary movement and they work with the cerebellum. The basal ganglia helps regulate muscle tone and the coordinate accessory movements such as swinging the arms when walking or gesture while speaking. The most common disorder of the basal ganglia is Parkinson disease. So, how the basal ganglia works? It will give the supportive movements to the voluntary movements, subconscious. Like I am explaining the concept. I am teaching you. So while teaching you, I am lifting my hands. Okay, and my facial expression is changing. My facial expression is changing, and sometimes while I am walking, I am moving my hands. So these are the subconsciously we are doing voluntary movements. Okay, so this is due to the help of basal ganglia. So the most common disease of basal ganglia is Parkinson disease. So we'll talk about Parkinson disease also. Next we have corpus callosum. So let's see basal ganglia. Basal ganglia, hippocampus, and corpus callosum all are related to each other. Okay, this is the basal ganglia. This is the basal ganglia. This is the hippocampus we have. This is the here you can see that basal ganglia. This is the basal ganglia. This is the thalamus. This is the hippocampus. Okay, basal ganglia. Okay. Next we have corpus callosum. As mentioned previously, the corpus callosum is a band of nerve fibers that connects the left and right cerebral hemisphere. This enables each hemisphere to know the activity of the other. This is especially important for people because of most of us, the left hemisphere contains speech area and the right hemisphere does not. The corpus callosum therefore lots lets the left hemisphere know that the right hemisphere is thinking about, and the right hemisphere know what the left hemisphere is thinking and talking about. Okay, so basically, corpus callosum is connecting the fibers of the right hemisphere to left, left hemisphere to right. So basically, like in the left hemisphere, we have speech area. So the right hemisphere want to know what happening. So that's the reason we have corpus callosum. Corpus callosum will also receive the information and it will transfer to the right hemisphere. Right hemisphere's information is transferred to the left hemisphere. Okay, this is all about corpus callosum. Example is given that a brief example may be help. If you put your left hand behind your back and someone places a pencil in your hand, you're not looking at it and ask you what it is, would you be able to say yes? You would. You would feel the shape and weight of the pencil, find the point and the eraser. The sensory impulse from the left hand are interpreted as pencil by the general sensory area in your right parietal lobe. Your right hemisphere probably cannot speak, but its thoughts can be conveyed by the way of corpus callosum to the left hemisphere, which does have speech area. Your left hemisphere can say that you are holding a pencil. Other aspects of the division of labor of your cerebral hemisphere beyond the scope of this, but it is fascinating subject that you may wish to explore further. So basically, one example is giving that if you are someone you are holding your left hand like this, someone gave you pencil. Okay, so if you are able to tell the about the pencil or not, because left hand is connected to the right area, so right area doesn't have speech area, left side have speech area. So if you put the pencil on the right hand, you will able to speech because your left side left hemisphere have speech area. Okay, but when you're putting the in the left hand the uh, pen, then the sense reach to the right hemisphere sense also reach to the left hemisphere. Corpus callosum will receive the information and send to the left hemisphere. In the left hemisphere, we have speech area. Then the speech area will tell you that whether it is pencil. What is it is? It is pencil. Okay. So this is all about corpus callosum transformation of information from left hemisphere to right to left. Hippocampus for memory, basal ganglia also for memory, but uh, involuntary movement with voluntary movement. Okay, so I think you understood this lecture. I think it is very, very important and very interesting knowing about your brain. So, whatever memory you are getting, you are stored, it is in the hippocampus. Okay, you are knowing that which part of the brain is working when you are thinking, which part of the brain, visualization, which part of the brain, okay, sense, which part of the brain, auditory, which part of the brain, smell, which part of the brain, social behavior, which part of the brain, learning skills, which part of the brain. So this is all about our learning our brain. So this is all about in today's lecture. Okay, tomorrow we'll talk about meninges and cerebrospinal fluid. I think it is very, very important. So some members doesn't join today. Okay. So it's hair loss. Okay. So we'll conclude today. If any doubts, you can ask.